In this video, we're going to do some problems where we simplify the absolute value expression. So we remove the absolute value from the problem, either by actually applying the absolute value, or we see what the domain is, and based on the domain, we can remove the absolute value. And I would really encourage you guys not to skip over this skill. It may seem trivial, but it's really important to be able to work with absolute values. They shouldn't be intimidating to you when you come across them in problems, and being able to analyze them like we're about to do in this video is the first step towards being really comfortable with absolute values. So these are the problems we're going to work. Let's get started. All right, this is very basic. What is the absolute value of minus 6? 6. Okay, now this seems trivial, but the idea is if you come across the absolute value of minus 6 in maybe a more complicated expression or in some situation, you know how to do this. You can get rid of the absolute value because you know how to evaluate the absolute value of minus 6. Okay, absolute value of 0 is 0. Okay, what if you came across this in a situation, in a larger expression or wherever? You could plug square root of 17 into your calculator and get a decimal, but maybe you want to leave the square root of 17 as it is. Is this fully simplified? No, this is not fully simplified. Okay, we know that the square root of 16 is 4. We know that the square root of 25 is 5. But again, this is a principal root symbol. So go watch the video where I talk about this principal root symbol. So this is not, if this was 16, then this wouldn't evaluate to plus or minus 4. If this was 25, this wouldn't evaluate to plus or minus 5. You return the positive root. So we know that the principal root of 17 is somewhere between 4 and 5, but not equal to 5 and not equal to 4. So since this is between 4 and 5, we know that this is going to be a negative answer. 100%, this is going to be negative. So knowing that, how can we remove the absolute value? Well, we say this, okay? You remove the absolute value, okay? And then since we know this is going to be negative, we put minus 1. You see? Then that will give you the absolute value because this is negative no matter what. We know 100% that square root of 17 minus 5 is negative. So whatever this is, if we multiply it times minus 1, we get the positive of it. Okay, we can still simplify this because we can get rid of the fraction. So minus 1 times minus 5, so we have 5 minus... Now this is fully simplified. Okay, so part A. So pi we know is 3.14 something something, which is greater than 3. So this pi minus 3 is positive. So how can we remove the absolute value? Just take it off. Okay. 3 minus pi. We know that that's always negative. So we can put a negative out front, 3 minus pi, and this once again is pi minus 3 when you distribute the minus. And so this you can think about, if you think about the number line, okay, the real number line. So this is, say this is 0. Well, let's just say we've got 3 here and pi here. Okay, how do you find the distance between 2 points on the number line? Just strictly the distance. You take the absolute value of either 3 minus pi or pi minus 3. And that's going to be this distance. And so it makes sense that we get the exact same number in both cases, because both of these represent just the pure magnitude distance between 3 and pi on the number line. Okay, so now this is the first time we have a variable within the absolute value, and then we're given a domain for the variable. Okay, and then again, don't discount this. You can have plenty of situations where you might have an absolute, in an expression, in a larger expression, you have variables within an absolute value, which usually, to me, when I was going through algebra and calculus and whatnot, the idea of having like a domain restriction seemed really rare to me. So if I ever had an absolute value inside or variables inside of an absolute value, it seemed like there's nothing you could do. And sometimes there is nothing you can do. You might have to leave it as it is with the absolute value. But in a lot of situations, you're going to find that like the question you're being asked, you can analyze it in both of these situations. You could say, okay, what happens when x is greater than or equal to minus 2? And then you remove the absolute value and then analyze the problem. And then you say, okay, what about when x is less than minus 2? And then you analyze the problem that way. And then you bring those two answers together. So in your journey through math and even in real life applications, you might be able to simplify an absolute value based on a domain restriction. So, okay, absolute value of x plus 2, but when x is greater than or equal to minus 2. Okay, well, when x is greater than minus 2, absolute value of x plus 2 is always going to be negative. So, since it's always negative, then we can remove the absolute value by doing this. But what about when x is equal to minus 2? Well, we get minus 1. When x is equal to minus 2, the absolute value of x plus 2 is 0. Do we get 0 here? Minus 2 plus 2, minus 1 times 0. Yeah, we do. So this is if x is greater than or equal to minus 2, the absolute value of x plus 2 simplifies to minus x minus 2. Okay, what about when x is less than minus 2? Wait. No. I messed this up. Okay, no. Greater than or equal to minus 2. So what we just did was part B. So if x is less than minus 2, then you might have minus 3, minus 4, minus 5. So your x plus 2 is always going to be negative. So that simplifies to minus x minus 2. Okay, if x is greater than or equal to minus 2, then x plus 2 is always positive. So you just take off the absolute value symbol. Now, when x is equal to minus 2, then the absolute value of x plus 2 is 0. When x is equal to minus 2 here, it's also 0. So this works. Okay. Part A. If z is greater than 5, this is always positive, no matter what. So we can just remove the absolute value symbol. Okay? So this is equal to 1. When z is greater than 5, that simplifies to 1. When z is less than 5, this is always negative. So we get okay, and this is negative 1. Okay, and this is like a function. You can, if these were combined into like a piecewise function, so we remove a and b. If we had f of z, this is like, so 1, 2, 3, 4, 5, 1, minus 1. Okay. Okay, this is if z is greater than 5, equal to 1. If z is less than 5, equal to minus 1. But there's no, it's undefined that z is equal to 5. And so you see, like, you can, if you can do like all kinds of typical analysis that you would do on a regular function when z is less than 5, right? This is a regular function here. It's a horizontal line, but it could be, you know, it could be anything. It could be, you know, whatever. Once you simplify the absolute value, it could be any kind of function. And if z is less than 5, you could do all kind of the same analysis you would do on a regular function. And similarly, if z was greater than 5, and you had whatever, you could do the same, you know, that same kind of analysis. That's what we'll do in once you get to calculus. You can sort of look at what's happening on one side of this discontinuity here, and then look at what's happening on the other side, and kind of combine your analysis together. All right, so that's it for this video. I'll see you guys in the next video.